The lesson outcome for this video is I can find the slope of a line. And we're going to do this from two different methods. One is from a graph, and one is when I give you 2 points, not necessarily with a graphed picture in front of you. All right, so we know that slope, we've been using slope for a while now, we know that slope, sorry about that, slope is rise over run. But let's make sure we understand what that means in more general terms. Slope is the amount of steepness that a line has. Okay, there are 4 different types of slope or steepness that a line can have. Let's take a look at them here quick. The first, positive slope. Okay, I'm just going to write POS for positive. Feel free to write the whole word there. Positive slope means it's increasing from left to right. It's going uphill. Well, how about the opposite of that? Well, downhill would be a negative slope, negative, because it's going down from left to right. The third type of slope is not going uphill and not going downhill, but just going very, very much horizontal, totally horizontal. So that is called zero slope. All right. It has no incline, it has no decline, it's just like walking along the ground at a normal, in a normal situation with no, no effort being put towards going up a hill, and again, no easier situation where you're going downhill. And the last one is a vertical line. And a vertical line, we say, is undefined when it comes to slope. All right, it's undefined. Think about this for a minute. Can you walk uphill? Okay, can we move uphill in some way? Yes, we can. Can we walk or move downhill? Yes. Can we walk along a hallway that is not going uphill or downhill? Yes. But is it a good idea to jump off of a cliff that's going straight down? Nope, not a really good idea, though you might find that that's adventurous and fun. We call that an undefined slope. Okay, so more on those later, but they should probably be familiar with you at this point. Those are our types of slope. All right, so the slope is the steepness of a line. Now, if I look at this line that's graphed on this coordinate plane right here, I should think about how it is going uphill, which means right away we know that we have a positive slope. Okay, we know we have a positive slope because it's going uphill. So if you find your slope and it's negative, well, you've done something wrong in your thinking or your math. So how is it moving with that rise over run? Well, rise means how much do we move up from a specific point, and then how much do we run or move to the left or right to get to another point. So if you see these 2 points on the graph, now sometimes they're going to be there for you, and sometimes you're going to have to just choose some points on a coordinate plane on your own. Think about where you would pick a point. Would you pick this point right here? Probably not, because although it's 1, it's comma 1 point maybe 6 right there, but we wouldn't have an exact value. You probably wouldn't pick a point like right here. Although this point is on the line, it's at like what, 1/2 comma, or not even 1/2 comma negative 0.2, right? Well, that's not very helpful numbers to use as we're doing our math. But this and this are right where we talk about these grid lines crossing, right there at the crossing. So we have -1, -2 for this point. And this one right here is at +2, +2. Remember, when we name points, we go on the x-axis first and then the y-axis. So if I move from this point to this point, the question is how much do I rise and then run to get from one point to the other? Well, in this case, we rise 1, 2, 3, 4 units. We're going 4 units up, so +4. And then we're going 1, 2, 3 units to the right to get to that point right there. That's also +3. So positive over a positive will become positive, which is good because it's supposed to be a positive slope. So our slope in this situation is 4/3. Which means that for every 4 units we go up, we have to go 3 units to the right in order to get to another location on the graph. Now, that means no matter where I am, and sometimes people don't realize this, let's say I'm right here, okay? If I move up 4 and right 3 from this point, I will still be on that line. So going up 4, 1, 2, 3, 4 is here, and then we move 1, 2, 3 to the right, and we are on the line right there. Okay, so go ahead and try this one on your own. Find the slope of the line. All right, so any 2 points on this line will help you find the slope, and you might have chose different points than I did. What if I picked this point here and this point here, but you had picked this point here and this point here? It doesn't matter, because no matter what, we're going to get the same slope. So from here to here, I have to go down 1 and right 2. So down 1 and right 2 means my slope is negative 1/2. Make sure it is negative because this line is going downhill. Okay, so this next example, the question says, if the points 5, 2, and 9, 4 are on a line, what is the slope of that line? Now, I'm going to come back to this coordinate plane in a little bit and actually show you visually what this is going to look like. But before I do that, I want to show you that you can find the slope between these 2 points using something called the slope formula. Sorry about that. All right, so the slope formula looks like this. It's m, which is our slope. We know about m now. Slope, or m, equals the y-coordinate of the second point minus the y-coordinate of the first point divided by the x-coordinate of our second point minus the x-coordinate of our first point. Now, it's very important that we remember that the y values, so 2 and 4, are the ones that go in the numerator, and our x values, 5 and 9, are the ones that go in the denominator. And then the other thing you have to make sure about is if I start with the second value for y, my second y coordinate in the top, in the numerator, I have to start with my second value in the denominator. Now technically I could do y1 minus y2 as long as I did x1 minus x2, but for whatever reason, this is the way the formula is written, and that's typically then what we'll use. So I'm going to go back up and I'm going to remind you, and I suggest that a lot of you do this while you're doing these problems, that our first coordinate is x and our second coordinate is y. Our first coordinate here is x and our second coordinate is y. Now what I'm going to do is I'm going to put some little subscripts 1 and 2 in to both of my points. So this is my first point right here. So I'm going to put a little 1 here and a 1 here. This is my second point right here. So I'm going to put a little 2 here and a little 2 here. Now all we need to do is put those numbers in the correct place in this formula and simplify. So m equals my y sub 2 value. Here's y sub 2. There's only one y sub 2 in this list. It's 4. So I'm going to put a 4 right here. Minus my y sub 1 value. Here's y sub 1. It's 2. Then my x sub 2 value, which is right here, so 9, minus my x sub 1 value, which is 5. Now I just simplify the numerator and the denominator, so 4 minus 2 is 2, and 9 minus 5 is 4. So we have 2 over 4, which we should simplify because that fraction is simplifiable, and we divide top and bottom by 2, and we get 1/2. So our slope is 1/2 for this line. Now what does that tell us? Well, it tells us that the line that has these 2 points on it will have a positive slope, so it's going to be going uphill at a rate of 1 unit up and 2 units over to the right. Now let's make sure that makes sense when we plot these points on our coordinate plane. So 5, 2 is right here, and 9, 4, 9, 4 is here. So our line looks like this, right? Now, does that line follow the slope that we've used? I'm previously counting our slope. Is it the same slope then as we got here for using the slope formula? Well, if I went from here, if I rise 1, 2, I rise 2, and I run 1, 2, 3, 4, I rise 2, and I run 4. And that is what I got, 2 over 4. which is 1/2. So it makes sense visually here as well as with our formula. Now, one thing that gets trickier with the slope formula is when any of these values have a negative in them, and when that happens, we need to be very, very careful with our integer work. But for now, if you understand the formula, that's a good starting place. All right, so like I mentioned on the previous screen, if we have negatives in our points, things get a little bit messier for some people, and sometimes people struggle with this. But again, use the same process for finding your slope. I'm going to first name this x and this y, name this x and this y. Since this is my first point, I'm going to put some sub 1's in there. And since this is my second point, I'm going to put some sub 2's in there. If you do that every time correctly, you're not going to make mistakes with the slope formula typically. Our formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Alright, so we're going to go ahead and fill in those values. M equals, our y sub 2 value is -3, minus our y sub 1 value is 4. And then the bottom, x sub 2 is -1, minus x sub 1 is -8. Now notice, I did have to write -8 here even though the minus was already there. This is when things get a little messy for some students. Rely on your calculator at least for a little while to make sure that you're adding and subtracting your integers correctly, and then later we want to try to, make sure we can do that on our own. So the first one in the numerator here, we have -3 minus 4. All right, -3 minus 4. If I am I always think about money here. So if I'm $3 in the hole, I owe somebody $3, and then I spend $4 more, I'm now $7 in the hole. So -7. Down here, I have -1 minus -8. Well, what happens with minus and negative? Minus and negative becomes plus. All right? Subtracting a negative amount of money or subtracting a negative is a positive. So now we have -1 plus 8. Well, again, if I am $1 in the hole, I owe somebody $1, but I get $8, I pay that $1 back and I still have 7. -7 over 7 can be simplified to -1 over 1 or just -1 for my slope. This is fine as well, of course, because we like slope written as a fraction anyways. All right, go ahead and try the second one on your own and check back to see if you have the correct slope. All right, you should get that the slope is 11 over -7, or you can also consider that -11 over 7 like this. It doesn't really matter as long as that negative is in just one location.